Hello students, how are you? I hope you are all doing well. So in today's video, we are going to study combination of capacitors. As we know that there are two types of combinations. First one is series and second one is parallel. Okay, so one by one we will study them. So first of all, let's start with series combination of capacitors. Okay, so here we are going to take two capacitors in series connection, like their capacitors are C1 and C2. So let's start it. We are assuming here assuming two capacitors with capacitance C1 and C2 respectively. These are the capacitance of the capacitors. So first of all, we'll start with series connection. Series connection. So first of all, we will draw the diagram of series connection and then we will find out the equivalent capacitance of the given connection, or we can say in the series connection. So let me draw the diagram. Let's say it's C1 and the second capacitor with capacitance C2, and they are connected with the external battery with voltage V and a switch K. Okay, so that's how the combination will look like. Here, as we know that according to the polarity of external battery, the current will flow. So here, let's say I current is flowing. And as we know that in series connection, there will be equal charge on the capacitors. So here the charge on the first capacitor C1 is Q and the charge on the second capacitor C2 is also Q. And as we know that the total charge on, we can say total charge of this connection is also Q. So that's why we are going to find out that what is the equivalent capacitance. So first of all, as we know that in series connection, there will be distribution of voltage. Okay, so there will be voltage V1 along capacitor C1 and the voltage V2 along capacitance C2. Okay, and the total voltage is V2. Therefore, here V equals to V1 plus V2. This is the total voltage, and the total voltage is going to uh, distribute in, we can say, along the capacitance C1 and C2. Okay, as voltage V1 and V2. Now, as we know that for a capacitor, since as we know for a capacitor, what is the equation of, like, the relation between charge, voltage, and capacitance? It is, okay, first of all, I'll write for the equivalent capacitance. So if equivalent capacitance is C, then what will be the equation for voltage V? As we know that the total charge is Q, so it will be Q equals to C times V. Okay, therefore, here the voltage V will be Q upon C. Finally, now we can say similarly for capacitor C1, capacitor C1, the voltage is, what will be the voltage across the capacitor C1? It is V1. So the equation will be formed as equation will be formed as V1 equals to Q upon C1. Okay. And for capacitor C2, the voltage is what will be the voltage along the capacitor capacitor C2? It will be V2 equals to Q upon C2. Now substitute these equations in the above equation where V equals to V1 plus V2. Now, okay, after substituting, we will get we will get Q upon C equals to Q upon C1 plus Q upon C2. So this will be the equation. And as we can see that we can take Q as common from the right hand side. So equation will be Q upon C equals to Q into 1 upon C1 plus 1 upon C2. Now, as we know that Q is in both the sides, RHS and LHS. So Q can be cancelled out and the equation will be formed as 1 upon C equals to 1 upon C1 plus 1 upon C2. So this will be the equation of equivalent capacitance where two capacitors C1 and C2 were joined in the series connection. Okay, so this will be the equivalent capacitance for the series connection where C1 and C2 were connected in the series connection. Now, if there are n number of capacitors connected in the series connection, then what will be the equation? Now, let's have one case that if n number of capacitors are connected connected in series combination, then what will be the equation? Okay, then the equation will be 1 upon C equals to 1 upon C1 plus 1 upon C2 plus 1 upon C3 plus and so on. It will be up to 1 upon C1. So that's how the equation will look like. Okay. Sometimes there is a misconception regarding these equations of the series connection for the parallel plate capacitor, that students what they do, they just put the values of C1 and C2 in this equation, and after all they solve the equation as C1 plus C2, 1 upon C1 plus C2, and they just find out the value of 1 over C only. Like it is not the we can say that it is not the equation, we can say final equivalent capacitance, that is 1 upon C. It is not the equivalent capacitance. Equivalent capacitance is C only. So therefore, for two capacitors, we have to write if 1 upon C equals to 1 upon C1 plus 1 upon C2. This is the equation to find out the equivalent capacitance. It is not the equivalent capacitance. So what will be the equivalent capacitance? So it will be 1 upon C equals to, here the LCM will be C1 into C2. Here it will be C2 plus C1. So therefore, the equivalent capacitance will be C1, sorry, C1 into C2, C1 into C2 divided by C1 plus C2. This will be the equivalent capacitance. This will be the equivalent capacitance. Fine. Now let's take another case when if n number of identical identical capacitors are connected in series. So then what will be the equivalent capacitance? Okay, this time we will write these identical capacitance of identical capacitors of capacitance C and equivalent capacitance as C equivalent. Okay, so the equation will be 1 upon C equivalent, 1 upon C. In place of 1 upon C1, we have to write C only. So it will be 1 upon C. For second also it will be 1 upon C, and for third also it will be 1 upon C, and so on up to 1 upon C, like n times it will be. Fine. Now, as we know that if we take 1 upon C as common, so it will be n upon C. So this will be the equation for equivalent capacitance. And as we know that we are interested to find out the equivalent capacitance only. So that will be C equivalent will be C divided by N. Okay. Sometime it has been asked in the question paper that n number of equivalent capacitance of some capacitance, for example, uh, 2 microfarad is connected in series connection. Okay, and their equivalent capacitance is this and this. So find out the number of capacitors. So these kind of questions are generally asked in the question papers. So if there will be n capacitors, uh, which like these capacitors are connected in the series connection, then those equivalent capacitance will be it will be reduced to nth factor of that. We can say nth factor of that capacitance. Okay, let's say, for example, the value of C is 12 microfarad. Like the capacitance of each capacitor is 12 microfarad, and we are having here n equals to 6 capacitors. 6 capacitors of capacitance 12 microfarad are connected in the series connection. Then what will be the equivalent capacitance? It will be 12 upon 6 microfarad, or we can say 2 microfarad. This will be the equivalent capacitance in this case. I hope you understood. Now we will start with the second combination, that is parallel connection. Okay, let's start. So second one is parallel combination. So let's draw the diagram first, how it will look like. That's how the parallel plate capacitors look like. Here the capacitors are C1 and C2, and it is externally connected with a battery of voltage V and a switch. Similarly, here also the current will flow from the positive terminal to the negative terminal. Okay, so in the first one, it current will be I1, and in the second one, current will be I2. Okay, and as we know that the capacitors are connected in the parallel connection, so therefore the voltage along capacitors C1 and C2 will be V only. Okay, because they are connected in the parallel connection. So here what will be distributed? The quantity current will be going to distribute along capacitor C1 and C2. Okay, so for example, we can say the current I1 is flowing through capacitor C1 and current I2 is flowing through the capacitor C2. Okay, so here we can say the charge is distributed. Okay, so charge will be Q1, the charge Q1 on the capacitor C1 and the charge Q2 on the capacitor C2. So in this case, the total charge is distributed in charges Q1 and Q2. So the equation will be Q equals to Q1 plus Q2. Now, for similarly, we can say as similar as the first case, we are going to use the equations of capacitor here. So Q will be equivalent to C into V, where C is the equivalent capacitance and V is the external voltage V. Okay, so let me write here C equivalent only, because sometime you will be getting confused that what is C here. So let me write C equivalent only, C equivalent into V. And the charge Q1 along capacitor C1 will be C1 into V, because we know that voltage is same, so we are not going to write here V1 and V2. And the charge on capacitor C2 will be C2 into V. Now let's substitute in the above equation. So finally we will get it will be C equivalent into V equals to C1 into V plus C2 into V. Now from the right hand side, we can take the voltage V as common. So it will be C equivalent V into C1 plus C2. This will be the equation. Sorry, I forgot to write here V. So the V and V will be cancelled out from RHS and LHS. And finally, we will get the equation as C equivalent equals to C1 plus C2. This will be the equation where two capacitors were joined in the parallel connection with the battery. Now, we'll again take the two cases. So first one is when there are n capacitors. Then what will be the equivalent capacitance when they are joined in the parallel connection? So it will be C equivalent equals to C1 plus C2 plus C3 and so on up to Cn. This will be the equation. Now let's take the example that identical capacitors are joined in the parallel connection. Then what will be the equivalent capacitance? Okay, for identical capacitors, what will the equation will be? C equivalent equals to C plus C plus C and so on nth time C. Okay, so the equation will be, because we know that we are adding a number of capacitors, so basically it will give us C equivalent equals to n into C. So here we can say that the equivalent capacitance will be nth time of the the capacitance of the single capacitor. Okay, that's how we can find out the equivalent capacitance of given connections like series connection and parallel connection of the given capacitors. Okay, they will give you the values of capacitance, or they will ask to find out find out the equivalent capacitance. What is the whatever we can say, they can change the variables, like whatever things they can give you the charge also, and they can ask you to find out, like if the equation contains three variables, then they will give you two variables and they will ask the third unknown variable. So similarly here also, you can find out the equivalent capacitance by the given variables. I hope you understood. If you have any doubt, then you can ask in the comment section. We'll try to solve in the next video. Thank you.